So the table of content includes 1. Introduction, 2. Definition, 3. Components, 4. Working mechanism, 5. Advantages, 6. Disadvantages, 7. Conclusion. So what is a network distribution system? The network distribution system is a reliable distribution system that is commonly used in urban areas that require high power demands. In this system, the distribution system is interconnected, forming a grid-line-like manner, allowing electricity to continuously flow even when one part is damaged, showing its reliability yet complex design.
Now we will talk about the components. There are 7 main components for the network distribution system. The first one is substation, which is a facility that receives high voltage electricity from transmission lines and reduces it to a lower voltage for distribution. It also helps control and protect the electrical power system. Next, we have a transformer, which is used to step down voltage levels so electricity can be safely used by consumers. It also helps improve efficiency and reduce power losses during distribution. Third, we have feeders, which are cables or conductors that carry electricity from substations to distribution areas. Their main function is to transport electrical power efficiently over certain distances. Now we have distributors. Distributors are lines that deliver electricity from feeders directly to consumers, and many homes and buildings are connected to distributors for power supply. Next, we have service mains, which are the final connection between the distribution system and consumer. They provide electricity directly to houses, offices, or other buildings. Next, we have protective devices, which protect electrical system from faults, overloads, and short circuits. Examples include fuses and circuit breakers that improve safety and prevent equipment damage. Last, we have transmission line, which carries electrical power over long distances from power plants to substations. They operate at high voltage to reduce energy losses during transmission.
Now I will explain about working mechanism. So first, how it works. It works by giving electricity more than 1 feet from the substation to the load. How the power flows. Electricity flows from transmission to a distribution substation where transformers step it down to medium voltage for local use. From there, it travels through primary feeders and can be sent through interconnected lines in a ring or mesh arrangement. What happens during normal operation? During normal operation, switch and protection device keep the network controlled so power can flow through the available lines without overloading equipment. In many systems, the load is shared among parallel feeds, which improve reliability and flexibility. What happens if a fault occurs? If one section fails, protection equipment isolates that a faulty part and the healthy section of the network continues supplying customer through the other available feed. That is the main advantage of a network system compared with a radial system which has only one supply phase.
Firstly, the network system is a very reliable system because electrical energy is supplied through various interconnect pathways instead of depending on a single route. This means if one transmission path has a fault, electricity can still be delivered through alternative paths, ensuring continuity of power supply. Secondly, this system is suitable for critical areas that require stable and efficient electricity supply, such as towns, airports, industries, and hospitals, where continuous power is very important. Another important advantage is that there is no single point of failure in this system. Because of this, the chance of a complete blackout are greatly reduced. In addition, the system is able to maintain reliable power distribution even during heavy load conditions, making it more stable compared to simpler systems. However, the network system also has several disadvantages. Firstly, it has a very high cost of installation and operation compared to simpler systems like radio and ring system, due to the large amount of equipment and infrastructure required. Secondly, the system design is quite complicated, requiring carefully planning and coordination between multiple interconnected networks. In addition, it is expensive to build because it needs a large quantity of cabling and electrical equipment. Furthermore, the system requires sophisticated control system to manage the flow of electrical power efficiency and safety. Lastly, maintenance can be difficult because identifying fault in an interconnected network is not easy and may take more time. In conclusion, although the network system is expensive and complex, it is highly reliable and suitable for important areas that require stable electricity supply.
In conclusion, the network distribution system provides a reliable and efficient method of distributing electricity. Its interconnected design helps reduce power interruptions and improve system stability. Although the system is costly and complex, it is highly suitable for areas that require a continuous and dependable power supply.